Welcome back, everybody. This week, what we're going to do is look at the different functional groups, or some different functional groups, that can be on carbon chains of organic molecules. We're going to start with a couple basic ones this week, the first being the alcohol group. Now, if you noticed from our first video on naming alkanes and such last week, that I said that there are many other functional groups like double bonds and triple bonds or other atoms that can entirely be added to organic molecules can have a pretty massive effect on what that molecule does. And here's one really solid example of that, which is the alcohol group. The alcohol group is characterized by an oxygen and a hydrogen attached to what's here I just write as R. R could be basically any carbon attached to any chain of hydrocarbons, right? So it could be this carbon here or this carbon here. It doesn't really matter. The R just represents a bunch of carbons and hydrogens with an oxygen and a hydrogen bonded to one of those carbons in that chain. Now, this is probably the most infamous of all alcohols. Okay, this molecule here has two carbons, so you guys know that this is when we're going to be naming this, we're going to be starting with ethane. But because there's an OH on this ethane molecule, it changes the name of this molecule to ethanol instead of ethane, and the OL at the end represents the fact that there is a oxygen-hydrogen bond somewhere on that molecule. So ethanol has lots of important industrial uses as a cleaning solvent, and we add ethanol to gasoline as well. But one of the big uses of ethanol is certainly the fact that it has an intoxicating property when consumed by biological beings like us. A lot of other alcohol compounds tend to be actually very poisonous. This is one of the few that isn't. And because of that, we have lots of really great uses for it. For example, if we move over to this molecule here, we'll notice that it has 3 carbons instead of 2. So we're going to be starting the name of this molecule with a pro. And it would make sense it would be propanol, right? There we go, because that'll add the OL ending to it to indicate that there's an alcohol in here. But there's a bit of a difference with this molecule, much like with the alkenes and alkynes. We have to indicate, once there's 3 carbons in this chain, which carbon the oxygen hydrogen is attached to. So at this point, we need to number our molecules once they get past the size of 2, and then indicate that actually this is 2-propanol. And that the OH bond is attached to carbon number 2. We'll get into a little bit more complex naming situations with alcohols a little bit later in the video. For now, we're going to move on to the second functional group that the lesson discusses this week. Let me just move a couple things out of the way here. There we go. And that is the alkyl group. Now, there's 3 different kinds of alkyl groups. You have a methyl group, an ethyl group, and a propyl group. These are basically small chains of carbons attached to the sides of other chains of carbon. So this would be a 1-carbon chain attached to the middle of a different chain of carbon. So like for the instance, this molecule here, there's a 3-carbon chain here, but there's an additional carbon hydrogen 3 attached at the top. Or like this one here, which has an additional 2 carbons. We would call that an ethyl chain. Then we're going to come back to that in a minute because that's actually not how we name that one. And in the molecule down here, you'll notice we have a long chain of carbons. And we have 1, 2, 3 carbons kind of sticking at the side of that chain. That would be called a propyl chain. This one's a little more straightforward. Whenever we have these chains, we really need to make sure that we number them. Because every time we use a methyl, ethyl, or propyl adjustment to the name, we are going to have to include the carbon number that represents where that chain comes off of. So in this one, we have 1, 2, 3. We got a 3-carbon chain here, and we've got this methyl group sticking off the side. Okay, so when we add methyl, ethyl, and propyl groups, they always go to the start of the name. And we begin with the number that it's on. So 2-methyl. Okay, to indicate that we have that CH3 attached to that carbon number 2. And then we're going to go propane because we've got 3 carbons. But wait, there's more. In fact, with this name, this 2 is completely redundant. And in fact, we shouldn't have it on there. And the only reason that we don't need the 2 on there is because there's only 1 carbon in this chain where a methyl group could be attached. If this CH3 was attached to this carbon, well, that would just make it a chain of 4, and that would be a butane instead. So since there's only this 1 carbon where this group could go, we actually don't need to put that number in front, even though it makes sense that it's there. For this one here, it's important to remember that we always have to count the longest chain of carbons. And it's very tempting just to go 1, 2, 3, 4, 5, and ignore the fact that if we take a turn down here, we can actually create a chain of 1, 2, 3, 4, 5, 6 carbons. All right? You always want to name that longest chain. It doesn't matter if there's bends or turns or whatever in there. You can always move in whatever direction you want when you're counting the carbons. Now, that makes this methyl group here my functional group that I'm going to have to add in. And because it's closer to this end of the chain than that one, I'm going to start numbering my chain from down here. So that's carbon 3, 4, 5, and 6, which means this methyl group is on carbon 3. So in this case, I've got 3 methyl, and then the chain is of 6 carbons, so that's 3 methyl hexane. Right? There's that methyl group on the side, hexane because there's 6 carbons. Sorry if that ended up a little bit blurry. Let's see if I can get a better view of it for you. The last one I want to do on this page is this guy here, which of course we have the simplified Lewis diagram for this one. Remember from the last lesson that each spot or sort of elbow on the chain represents a carbon with all appropriate hydrogens attached to it. So in this one, we have to count, as always, the longest chain, which is 1, 2, 3, 4, 5, 6. And now I got to decide which way I want to go. Well, here's the thing. It doesn't really matter because I got 7, 8, 9 this way, or I've got 7, 8, 9 that way. So which way you want to go, if you want to go up here or down there, doesn't really matter. What does matter, however, is that we start from this end of the chain. Just like with the last question, we had to make sure that we start from the end of the chain where the functional group is going to come up with a lower number. So they got 1, 2, 3, 4, 5, 6, 7, 8, and 9. And here I've got 1, 2, 3 carbons, so that makes this a propyl group because there's 3 attached there. And that's on carbon number 4. So that is going to make the name of this molecule 4-propyl for the propyl group, and then nonane because we have a 9 carbon chain. All right, we're going to try a few examples together. Let's just see if we can name some of these molecules that we just talked about. They're all just alcohols and alkyl groups, so you're not going to see anything too fancy here. The only thing we're going to do is discuss what happens if there are multiple groups on a molecule and how we name that. We're going to get to that one next, so sit tight. That'll be very exciting. I'm going to use red for this one just to have it stand out a little bit better. So here we have an alcohol. We can see the OH group hanging out right here on carbon number 2. Why do I know that's carbon number 2? Well, I'm going to name from this direction because I want to get, again, that OH on the lowest possible number. So I've got 1, 2, 3, 4, 5. So this must be 2 because it's 5 carbons. That's got to be pentane. The OH makes it pentanol, and it's on carbon number 2. So I've got 2-pentanol. Is the name of that one. Not too bad. Right? That one's pretty straightforward. So let's get to one where the quantity of hydroxides is what's going to make this a little bit more challenging. So this one, we have a carbon chain of only 2, right? We got 1, 2 carbons. Now, I'm going to number these. I'm going to start with this carbon here, and I'm going to make this carbon number 2. The reason I'm doing that is because this carbon has more hydroxides on it than that one. Why does that matter? Well, The hydroxides could be split up, all 3 on here, could be 2 on this one and 1 on that one, or the other way around. So because of that, we're going to have to refer to each carbon separately to describe where its 3 hydroxides are. Now, because there's 3 hydroxides, what we're going to do is we're going to separate the carbon numbers with a comma. So this hydroxide is on carbon 1, so that's going to be 1. And then this hydroxide is also on carbon 1, so I'm going to write a second 1. And this hydroxide is on carbon 2, so that's going to be a 2. So 1, 1, 2. And that 1, 1, 2 indicates that I have 3 hydroxides. 2 hydroxides are on the first carbon, and 1 hydroxide is on the second carbon. Okay, this is still ethane. But we can't just say ethanol because just using OL is going to indicate there's only 1 hydroxide. So we're actually going to call it ethane triol instead. I know that's kind of a weird way to end that. Instead of ethanol, we'll call it ethane triol to indicate that there are, in fact, 3 hydroxides in my molecule. Right, so we got 1, 1, 2, ethane triol. Next, let's go to the simplified Lewis diagrams here. This one is a little bit more straightforward. There's only 4 carbons to deal with. Hopefully you guys recognize at this point that, again, we have to number from the right side to get that hydroxide on the lowest possible value. So that is going to be 2-butanol. There we go. Right? 4 carbons means butane, and the OL for OH, and the 2 for the location of it. The last alcohol we're going to do is this one here. You guys can probably guess we're going to be using the triol ending again because we've got 3 hydroxides. And of course, like all of our previous examples here, we are going to start numbering from this side. 4, 5, 6, 7, and 8. Again, just so that the hydroxides are on carbon 2, 4, and 6 instead of carbon 3, 5, and 7, which is what they would be if we did them the other way. Always aim to make the numbers as small as possible. Now, first off, I have 8 carbons on there, so this is going to be some kind of octane. It's going to be some kind of octane triol. Right, just like our ethane triol here, we know it's going to have that triol ending. It's going to be octane with the triol there. And just like the 112 ethane triol, we are also going to number the 3 locations of the hydroxides, which are on carbons 2, 4, 6. So we're going to write a 2, 4, 6 dash at the front of there and end up with 246 octane triol. 246 for the carbons, octane because there are 8 of them, and triol because there are 3 OHs. All right, let's move on to just a couple final examples for alkyl groups. All right, so when you have some alkyl groups in here, again, like all cases, you want to number your longest carbon chain. This is one where identifying the longest carbon chain might take a minute or two because there's a lot of carbons kind of hanging out the side here. We've got 2 here and 2 here. So we can go actually right across the molecule here, but again, I don't know why I did this with every single one, but we do need to start from the right side here because the first 2 carbon chain off the side is going to be closer to the side of the molecule. All right, and what do we have? Well, I have a 1,2 carbon chain here, so that is an ethyl group. And I have a 1,2 carbon chain here, so that's another ethyl group. Because there's 2 ethyl groups there, we're going to be adding the prefix diethyl to our molecule, which is an octane. But we have to make sure that we indicate which carbons our 2 ethyl groups are on, and they appear to be on 3 and 5. So we're going to go 3, 5 diethyl octane. And I just realized now none of you can see that. So let me move that over there for you. 3,5 diethyl octane there. We have an ethyl group on carbon 3 and ethyl group on carbon 5. So there's 3,5 diethyl and octane because there are 8 carbons in that chain. All right, we only have one left. And it's this one down here. Again, we're going to go back to the simplified Lewis diagram. If you guys are like me, it's going to be kind of nice because it takes all the extra stuff that you don't always need to know when you're naming the molecules, like the hydrogens. You guys probably noticed the hydrogens don't ever come into the names. We just kind of assume that the carbons are filled up with hydrogens wherever they don't have anything else to bond with. And therefore, we can kind of ignore the hydrogens and molecules. We kind of take for granted that they're there. So in this molecule, we have, hopefully you can see pretty easily that the longest chain is just going to be right across the molecule because these methyl, methyl, and methyl groups do not take up enough real estate to change the location of the chain. So we just have to count across, and it looks like this time we can actually count from left to right, which is so nice. Because we've got 3 carbons on that side, but 4 on that side. So starting on the left side is actually going to be better. So let's go 1, 2. Looks like we have a 10 carbon chain here. So this is going to be some kind of decane. And this decane has a methyl on 4, a methyl on 5, and a methyl on 6. So that'll be some trimethyl that we'll be adding on to here. And we need to indicate which carbons those methyl functional groups are on, which are 4, 5, and 6. So we're going to put 4, 5, 6 trimethyl decane. And that is the name of that molecule. If you have any more questions about naming molecules, drop me an email anytime. I'd be glad to go over anything you like. Just a reminder, there is no quiz this week, but my pet element is due on Friday. So if you get that to me this week, that'd be great. Probably be a quiz next week. I think just simple naming stuff, but I don't want to give you one this week because you have a big assignment to do. Have a great week, everybody.